Circle theory, as the name implies, is about circle, right? So something like this circle. So you can look around you, something in circular shape, right? So this is what a circle. But the theorem here is something that has already been proved to be true, right? So what I mean by that is that as the time of making this video, today is what Thursday. Is that okay? We have a Thursday here, and then of course tomorrow will be what, Friday, right? So tomorrow will be Friday, and yesterday was what, Wednesday. This was something that we all know to be true, right? Which is a fact, a true fact, right? So today is what, Thursday. Tomorrow will be Friday. Yesterday was what, Wednesday. So the idea here is that when you say circuit theorem, something that has already been proved to be true, we are just going to use it to solve what our problems, that any problem that they will give it to us. So here in all we have what, the basic one. We have eight tools, accordion tools, right? So 8 tools, or maybe eight definitions, or whatever you want to call it. So 8 definitions, or maybe a proof or property, right? So that we are going to study here and see how to use them. Is that okay? So in all we are going to have a look at 8 tools and our circle theorem. But before this one, we have another one that is a plane geometry one. So if you don't have any idea on that, maybe along the road I will explain that. If you wish to watch that, you may check our playlist on what, the plane geometry, if you have any detail. Now here's the first one. Now the first one that we have here is that I would advise you to learn this topic with what, a picture, right? So the idea is that we should learn this thing with what, pictures, right? So learning this thing with pictures means that you are going to avoid the technical definitions. So what I mean by the technical definition is that the mathematical definitions of the circle theorem. So I would advise you to learn this thing with a picture. So once you see the picture, you know that this is exactly what they are trying to say. Okay, so here's the first one. So if you have a circle here, circle with something inside, right? So that's what we are going to study here. So let's say you have some angles inside of this circle here, right? So let's say you have some angles here. Is that okay? So angles like this, and then something that looks similar to this, and then you have one that goes this way. So this one will be somewhere here, right? And then there's another one that will be here, right? So you can see this is the circle, and then we have some people inside of the circle. So the definition here is that this is what we call a segment. So a segment. So this is a segment, right? So let's say a segment means that these people are all starting on the same ground, right? So they are all starting on the same day, something of that nature, or at the same level. Is that okay? If that happens here, whoever is here, whatever you are having will be the same thing that this person will also get. It will be the same thing that this person will also get. Does it make sense? So there are 3 people in this circle here. First thing is that they all have to start on the same day. So what I mean by the same day is that this is the same segment, right? So this is the segment, and then the substance are the chord, right? So for you to avoid the mathematical definition, study this thing with a picture. So once you see that these people are starting on the same ground, and then here, whoever is here, whatever we are going to get will be the same thing that this person is also going to get. Will be the same thing that this person is also going to get, right? So the definition of this thing is that A is equal to B and A is equal to C, right? So if our A was let's say 30 degrees here, of course this B will also be 30, and then C will also be equal to 30 degrees. But don't forget to watch the video to the end, whereby we bring you some exams questions on how to use all the definitions that we are going to learn here to solve a pure exams question. Now this is just for the first part, so let's look at the second part. So this will be the second property that we are going to study here, right? So let's say, of course, we are dealing with a circle theorem, so everything is inside a circle. So assuming this is the center of the circle. So the center of the circle here, we have one angle that goes like this, and then there's another one that goes like this. Is that okay? And then here comes the second one. So if you extend to this point here, right? So if you extend to this point here, all that we are trying to find here is that we want to know the angle here as well as the angle here. Is that okay? So look at the shape. As I said earlier, I want to make sure that you learn this thing by a picture. So look at the shape of the angles that we are having within this circle. So here, what we are trying to say here is that if 2 times of whatever is here will be equal to this guy. So let me explain that. So let's say you are here, you are 10 years old now. So you are 10 years old now, you are here, right? So let's call you A. So you are here, you are 10 years old now, and then maybe let's say your sibling is here. Your sibling will be 20 years old. Does it make sense? So whatever is here is what 2 times the down here, right? So you can see, maybe by picture you can see that this one has a very large portion here, so that one should tell you that whatever is here will be bigger than the smaller side here. This has something like a pointed angle here, right? Okay, now by definition this one should tell you that 2 of what your A here is equal to what? Is equal to B, right? So 2 of A is what? Is equal to B. So that is the mathematical definition. So upon what I've explained here, meaning that the the angle here should be half of whatever is here. Does it make sense? So if here were to be what 50 years old, here will be what? Here you should comment down below. So what will be the value of whoever will be here, right? Okay, so just comment down the answer for this portion below. That's very simple. So the definition is that the angle subtend at the circumference of the circle. So this is what we call the circumference, right? It's twice the angle at the center. So let's call the center here O. So at the center of the circle. Is that okay? So this is very simple. Once again, make sure that you watch this video to the end, whereby we solve some problems relating to all the properties that we are going to learn. If you enjoyed the video so far, don't forget to subscribe to our YouTube channel. Like and comment down below if you have any questions so far. So looking at this one here, so look at the shape very carefully, right? So if you go like this, and then this one is what one triangle, right? So the top here is one triangle, and then there's another one facing it down. Is that okay? So this is the shape. Now all that we are doing here is that to determine the angles, right? So relating to what? A circle. So that now that let's say you are here, so here throughout we'll be using A and B. Is that okay? So let's say you are here, so let's call you A. You are here right now. This is your portion that you are having, and then you have a friend here, that is at the down here, right? So your friend is also located somewhere here. Is that okay? So both of you are facing each other, right? So if both of you are facing each other, or the definition that we have here is that if you add whatever you are having plus whatever your friend is having, that should be equal to what? 180, right? So here we have that A plus or B here should be equal to what? 180 degrees. Is that okay? We don't care whatever you are having, we don't care whatever your friend you are having. All that we know here is that if we add the two of you here, your summation should be equal to 180 degrees. So if you, let's say, suppose that you are having what 70 here, what will be the value of your friends here? So 70, it will be 70 plus what? Plus B, which is at the down here, it will be equal to what? 180 degrees. Is that okay? So therefore you have what? Your B here to be equal to what? 110 degrees, right? So this is what just a simple definition of this method. The most important thing here, you have to look at how the shape looks like before you can apply the method, right? Okay, so that is there. So the next one here, that you have the one that passes through the diameter, right? So what I mean by the diameter is this is the center of the circle. So if you move from here to the end here on the straight line here, we call it diameter. So this guy is what we call a diameter. So these are some of the keywords you have to pay attention to when you are solving the problem. Also, I say you should stay to the end of the video and see how we can apply some of these method in solving the exams question. Okay, the most important thing is that you have to pass through the center. You have to form a diameter, right? So once you form the diameter, if you move from here, one end of the diameter, and then you hit somewhere at the circumference, so let's say you hit at the edge of the circle here, right? So you can hit anywhere. Is okay? The most important thing here is you have to start at the end here. You don't care whatever you hit on the circle. Once you hit on the circle, and then you manage to move to the last end, the next end of the other diameter. So from the diameter number 1, the end here, to anywhere on the circle, and then you move to the other end here. What that we are going to do here is what will be the angle. That's the most important. So the angle that we are going to have here will give us what? A 90 degrees. Is that okay? So the angle here will be what? 90 degrees. It is very important. So when can we get a 90 degrees? We can only get that one if you move from here, the end of the diameter. The first step is you must pass through the center of the circle, right? So end to end here, that gives us the diameter. So once you get the diameter here from one end here, you must hit anywhere on the circle. Is that okay? Once you hit on the circumference, the edge of the circle here, and then you manage to move to the last end here, right? So the angle that is formed here is what? 90 degrees. we don't care about this, we don't care about this one. So what I will know here is that once you're able to satisfy this condition, here will give us what, a 90 degrees, right? So it can be the other way around. So let's say you are here, you move from here, then you manage to hit the circle somewhere here, and then you move on straight to what, to the end of the other one. Here will give us what, a 90 degrees. Is that okay? And that is all that we know for this definition, right? So make sure that you still connected. If you're enjoying, once again, subscribe to the channel, comment down below if you have any question. But what will happen if you have something like this? So let's say this is a circle, this is the center, this line doesn't pass through the center, right? So this line doesn't pass. Is it a diameter? That's the first question, right? So, and then here you move here, and then you manage to go this way, right? You manage to hit at the end here. Exactly. Will here be what? 90 degrees. So that's a big question mark here, right? So will this place be 90 degrees? If yes, comment down. If you know, just make sure that you comment down below. Is that okay? So this is the center. Is that okay? You didn't pass through the center. Here, will this portion be what? 90 degrees. So comment down below your solution. So this is another beautiful property here. Now just look at the picture here, right? So let's say you have a twins or a triangle in a circle. So this is the first twin brother here, and then you have another one that looks like this. Okay, so the idea here is that always you want to determine the angles that they are forming, right? You want to determine their angles that they are forming. That's the most important thing here. But here, what I mean by the twins here is that this line here is equal to the line here, right? So it's, let's say, from here to this place here, let's say you can take, let's say, 5 kilometers to get there. It will be the same 5 kilometers that you are having here. Is that okay? That is why you have this symbol there. Now, if this thing happens, whatever is here, the angle that will be here will be the same angle that will also be at this portion. Right, so once the distance from here to here is the same as well, the distance from here to here, which is 5 kilometers, and then 5 kilometers here. Does it make sense? So once that happens, then the angle that will be here will be the same angle that whatever you have will be the same thing that the other person will also get. So okay, so if here were to be 5, here will also be what? Be 5. Provided that this and this also are equal. Is that okay? So if this is equal to that, whatever is here will be the same thing. So for that reason, we say that A is what? Equal to B. So if you are calling this portion here to be A, and then here will be B, right? So does it make sense? So the condition here is that this line here has to be equal to the line here with this symbol, right? So mathematically, if you see this symbol, meaning that they are equal. That is very simple definition, right? Is that okay? Okay, how to apply it is the most important thing. So for you to get a concept here, you have to try solving some problems along, right? So, okay, now here's the second one. So if you have a line that passes through the diameter, once again, is that okay? So if it passes through the diameter here, let's say you have another twins here that looks like this, right? So note the difference between the first one and the second one. Look at what is happening. So this is the center, right? So here, this is the center. So if all of you are meeting at this point, so this is your meeting point. Is that okay? So this is the meeting background here. If all of you are meeting at this point, and this line are equal, right? I've already explained the meaning of the equal from the previous property. So if these people are equal, and then 2, you are meeting at the center here, whatever is here will be equal to whatever is here. So whatever you get will be equal to whatever this person will also get, right? So just look at the picture. So that's what I say. The definition of this, and they say a chord substance at the center of a circle are equal, right? So a chord substance at the center of a circle, that's the most important thing, are equal. So whatever will be here will be the same too. So if here will be S and then here will be Y, so we consider S is equal to Y, right? This is just a definition. Something has already been proved to be true. Is okay? So we just need to apply it and solve it. Very simple. So these are the now let's look at the next 2 properties. So we are done with wassce, right? So once again, don't forget to give us a thumbs up, subscribe to the channel, comment down below if you have any question. So be alert. We suggest that you should write some of these things in order, right? So when you start solving the problems, you won't be have any issue along. So this is the next one. So look at the shape here. Now we have the circle, right? So you have the circle, and then we have a triangle inside the circle, right? That is 1 point. And then we have another line here, another road here that passes through and touches the circle. Is that okay? So we call this line here a tangent, right? So we call this one what? The name of this line here is a tangent. It is a tangent because you manage to touch anywhere on the circle. Is that okay? You can touch it. It can be like this and you can touch it, right? Once you touch here is what we call it what? A tangent. That's the most important thing. So mathematically, once the line that passes through outside from the circle and then touches the circumference of the circle is what we call what? A tangent. So two things you have to pay attention. So you have the circle, you have another triangle inside the circle, and then you have the tangent. Now you want to determine the angle here and then the angle that is forming with the tangent. So look at the portion here. So I guess students normally make mistake when they are finding this one. So pay a close attention. It is the angle from here, right? From here to here. Is that okay? So from here to here, the angle, this angle here and this angle matter that we are talking. So if you are calling here theta and then we call here theta is not anything. Theta is just any number, right? So whatever is here will be the same thing that will be here, right? So look at this angle very, very well carefully. Is the angle, the line here to the tangent, right? So the line on this to the tangent is what we are talking about. So if you here were to be 70 degrees, so for sure everything here will also be what? 70 degrees, right? Well, that is what another property. They are very, very simple, but how to apply them is the most important thing. Is that okay? So now, finally, this is another thing relating to the tangent. So I've already explained the meaning of the tangent here. So you consider a line from outside, right? From any point here, touches the circumference. So this is the circumference of the circle. Is that okay? And then if you manage to move to the center, so here will be the center. So we are calling it the center. We are not saying you should move to anywhere within the circle. Just move straight to what? The center. So you manage from here and then you touch the circumference and then you move to what? The center here. Here will give us what? 90 degrees. Is that okay? So this portion here will be what? 90 degrees, right? So here, this line will be 90 degrees as well as what? Here will also be what? 90 degrees. So does it make simple sense? So that's just a simple understanding, right? So you move anywhere outside the circle here, is that okay? And then you touch the circumference, then you move to the center. The angle that we are going to form here is what? Is 90, right? So this symbol here stands for what? 90 degrees. Is that okay? We don't care about this. We don't care about this one. Maybe you'll be giving, right? So here the most important thing is that here give us what? A 90 degrees. So this is what? Another tangent, right? So the reason why it is a tangent, we call it a tangent, is that you manage to touch this what? The circumference of the circle. You don't pass through, right? You don't pass here. Is that okay? You don't pass here. You touch this what? The circumference and you move toward the center. You didn't go anywhere. You didn't go anywhere like this. Is that okay? You move straight to the center here. Then here give us what? A 90. This is what we know. We don't care about this. We don't care about that one. Is that okay? So these are some of the properties under circuit theorem that you have to pay closer. I guess you should go back, check them one by one, and then we start solving the exams questions. We want to solve some of the questions relating to circuit theorem using the information that we've learned so far. So let's have a look at the question. Straightforward, we have been asked to calculate angle MLN. So this is the symbol of what? Angle, right? So you can write it in word, but in case you see this symbol, it stands for angle. They say MLN, meaning that the angle is formed at what? L, right? So the angle is meeting at L. So if you have something like this, so the L here, right? So this is the angle that we are talking about. Is that okay? So looking at the diagram here, this is what we had from the question N, or maybe M, L, N, right? So M walking this way, L, and then moving this way to N. So this is the angle that they are asking us to find. Okay, so the keynote here of solving this thing is to pay attention to the information being given to you. We hear the word chord from the question. That tells you that you have something relating to a chord what? Definition, right? So what I mean by the definition here is the theory, right? So the information that I gave to the tools that you are going to use to solve this problem. And then the second one is the parallel. So the word parallel tells you that you have to use something that relates to alternate angles, right? So alternate angles are equal, or maybe corresponding angles are also equal, right? So these are some of the keywords. And then finally you hear the word diameter. So the diameter gives you the idea that you have to use that property relating to the diameter. Is that okay? So the diameter, if you have a circle like this is the center, right? So this is the center that we are having. So if the line passes through the center and then hit anywhere the circumference and then move to the last end here forms what? and 90 degrees. So the word diameter gives us the idea that we have to use this in some way in our problem solving. And then the parallel also tell us what to use the alternate and the corresponding angle, right? Any one of them, or maybe two at the same time. The chord move on to the other property. So let's see how to use this thing. Based on the information that we are having, we have been asked to find angle what MLN, right? So ML. Here's the information. So since KN, right? So this is how you should write your solution. So since KN, so this road here, the road starting from this town here to the town N here, this road here, we are told that it is what? A diameter. Is that okay? So the diameter, this one gives us the hint. The idea is that this one gives us the hint. So look at something. This guy starts from one end of the diameter, hits the circumference, but it doesn't go here. Can you see that? It doesn't go here, right? So what about here? Here to the same thing. If you start somewhere here, and then we don't see any line that goes to the last end for us, or that guarantees to use that one side will form a 90 degrees. So the key note here is that you have to extend one line, right? You have to extend one line to the point. Remember, we don't clean anything, you just add up. So from here we can extend this line, right? We can extend this line to this point. But why are we doing this? We are doing this for us to apply that method. This everything here will be what? A 90 degrees. Do you agree? So if you move here and then you hit somewhere at the circumference and then you come back to the last end here, here will be what? A 90 degrees. So this is a symbol of what? 90 degrees. If you are told that everything here is 90 degrees and then here is 61, so 61 here what will be the value of this guy here? So this is how simple you have to solve this problem, right? So the angle LPK, right? So the angle LPK, so LPK here is what we are going to look for. So that will give us what? A 90 minus 61. That will be what? 29. Is that okay? So this angle will be what? 29. The question here is why are we solving that angle here? Because we have been asked to calculate angle MLN, right? So this angle. Is that okay? So how to get there is exactly what you are doing here. So these are some of the things that you have to pay close attention to. So if you hear what you got 29, right? So this side here is what 29 degrees. Is that okay? And then remember the another key word here is the chord, right? And then the parallel. So now we are done with the diameter, right? We are done with the diameter idea. What about the chord? Can we use that chord idea and the parallel to get exactly where we want to move to, right? Okay, so now you can see that this guy here is 29, right? So this guy here is also, so there's a 2 relating to the chord that says that if all of you start at the same segment, right? So something like this, right? If all of you start, let's say you have one here and then all of you are starting at the same segment. Can you remember this definition? So here to here and then here. So this is how the structure looks like, right? So all of you are starting at the same segment. This angle here is the same as the angle here. Is that okay? So all of you starting at the same segment, right? So that's the same. Then angle a chord. Is that okay? So this is the chord here. You are hitting the circumference of the circle because all of you are starting. Remember that definition. You may go back and go and check that, right? So here will be what? This angle, whatever here will be what? The same thing. That's the idea that we are going to use here. So you see, this may look somehow complicated to you, but it's not complicated. Once you see what you use, just pick it out. So you can see that this is what one structure here from here and then to here. Is that okay? So there's one structure. Can you see? So this is a structure from here. Is that okay? To here and then to this place here, right? So there's one angle here and there's one angle here. Can you see? Can you see this thing here? There's one angle here and there's what? One angle. So all of them are starting what? At the same segment. Is that okay? Or maybe they are starting at the same segment from this portion, right? So from this portion you can see that. So if here is what? 29, here also be what? 29, right? So by that definition, so this portion here is 29. Here also has to be what? 29 based on that definition. So how do you write that? So you can say that angle at the same what segments are equal, right? Angle at the same segment are equal. So that is a simple English and a statement here. So this means that the angle LPK, so LPK, where is the LPK here? So the angle which is 29 is equal to angle angle what? Is equal to angle KNL. So K and then N and then A. Have you seen? So the angle here. It's okay. You are just applying the definition and the method. So here also be 29, right? So this portion here will also be here will be 29 degrees. Does it make sense? Now, gradually we are getting there. So now we are left with the parallel condition. So this parallel guarantees us to use the idea for alternate and what corresponding. Is that okay? So which one are you going to use here? Once they say two lines are parallel, if you want to see more videos on this thing on parallel and then first part of a plane, I'll leave a playlist in the description below, so you may consider watching that. Once you hear the word parallel, meaning that we are going to use the alternated. So the alternate here gives us something like a Z shape. So the alternate, if you say two people are alternate, here and this place are equal. So if you hear it's for 40 degrees, here will be what? 40 degrees, because these two lines are parallel. So if they are not parallel, you cannot apply the alternate or the corresponding, right? So now we are told that this line here is parallel to this line. So we can see the Z shape here. So look at it. So if you walk like this, right? Like this and come this way and then go like this, you can see that gives us a Z, right? So this like this and then that goes this way or like that. So here will be a Z. So this angle here alternate to what exactly they are asking it to find, right? Can you see? So that's just a simple trick there. Is that okay? So the alternate gives us what? A Z shape that looks like this, or something that goes this way. Is that okay? I have a full video on this thing, so you may consider watching that in the description section below. So the angle here is exactly what they are asking you to find. That is the M and then L N, right? So this angle here. So this one alternates the portion here. So that is exactly what I'm having here. That's since the alternate angles are equal. Is that okay? Angle K and L is equal to angle MLN, which is equal to 29. So this is exactly what they are asking us to find. Let's look at the next question.